So let's look at an example of an improved workup process and the sorts of improvements we can bring around. So this is the reaction here. It's a reaction to form this heterocycle on the right. And this is a classic SN2 reaction. We have an inorganic base and a dipolar aprotic solvent, so potassium carbonate and DMF. This was changed for a phase transfer method, and if we look at the figures, certainly the phase transfer method in water used slightly more solvent in the reaction, but because the workup and isolation could be greatly simplified, overall the phase transfer catalyzed process was much more efficient in terms of litres of solvent used per kilogram of product. We can see the figures here, and that's primarily due to really cutting down on the amount of solvent and water used to isolate the product from the reaction mixture. So the benefits of this new process, PTC versus DMF, well, we've taken out a reprotoxic solvent, so DMF is a reprotoxic solvent. We've improved the workup procedure, so we have a 50% reduction in solvent and water used per kilo of product. We've isolated the product directly by crystallization from the reaction mixture. Okay, so in the phase transfer process, we just add ethanol and the product crystallizes out. In the DMF process, we have to dilute with water, organic solvents, do multiple liquid-liquid extraction, so we've avoided that. Better throughput. Fewer solvents used. In the DMF process, we use always organic solvents, processed water primarily in the workup. In the phase transfer catalyzed process, we only use ethanol, which is added directly to the aqueous reaction mixture. Of course, we now have a much simplified process waste stream, of course. The DMF process produces both aqueous organic and mixed solvent waste to deal with. So we have a much simpler waste stream for disposal.